Remember, if I have a difference of squares, here's our little pattern. Difference of two perfect squares, make this bigger. Then we did one as a difference, one as a sum. Okay, spend a day or two doing those. And then our perfect square trinomials, this is when I would have the a plus a b, and then that quantity squared. That's when we kind of did all of our little squares. This one isn't quite as important to get the pattern memorized, but definitely these differences of squares we need to know. If this is a minus sign, we would do the a minus b squared. Okay, so the first one, same thing. You could have done this last night for homework. If I had put this on the homework, so let's actually see if we can do it now. You would be able to do this one, and I would have hoped by the end of that homework, you would think this is an easy one. All right, so do number one. Everything is perfect in terms of what we talked about yesterday. We want it to be set equal to 0. That's done. We want these to be in descending order, x squared, x to the first, and then no x's. So everything's perfect right now. This is ready to be factored, and it's ready to be solved. All right, so do that real quick. Tell us more than anything if we understood what you did for homework last night. All right, Monica, what numbers did you come up with, Monica? What numbers did you come up with here? Good. Positive 4 and positive 4 multiplied to be 16. If you add them up, you're going to be an 8. So this is now kind of, it's the same thing we've been doing. It's a little weird, unique case, certainly not necessarily a hard problem. What would this solution to this one then be, Monica? Good, negative 4. And then if I ask you what would the solution to this one be, what would you have told me? Good. So don't they give us the exact same answer? Okay, so that's legal, not a problem. You don't need to write both of them down. This case, we only get one answer. So even though we have these two different factors, yesterday we were getting 2 factors, 2 answers. This case, they ended up being the same, so we technically only get that one answer. Okay? All right, number 2, before we do this together, try that guy. So it's in the right order. We have it set equal to 0. That's necessary. And then these are in descending order. You have your w squared, and then you have your 36. So this is a binomial. See if you remember the 2 things you look for to factor a binomial. And then write down what you think your answers are, if you get that far. All right, Caden, what is the first thing we always look for? Good. So the first thing we always look for is a greatest common factor, always. Sometimes they have them, sometimes they don't, but we always check for it. So in this one, did you find one, Caden?
4.
Good. There is a common factor of 4. So we're going to pull out a 4. If I divide that by 4, I just have a 1 and then w squared. And then if I take that 36, pulled out the 4, that would leave me with a 9, and then that is set equal to 0. All right, so old stuff. We're just doing it now with the whole little equation set equal to 0. All right, second option with a binomial, so we just have this term and the second term. It's a binomial, is to determine if we have a difference of squares. So that then is now looking at what we have left over. Definitely a difference, we're subtracting. And then are both of these terms perfect squares? Yeah, so that means that goes further. So this is one that not only do we have this extra 4 in front, but I can factor this down to be a w minus a 3 and a w plus a 3. And then that would equal a 0. Write down your answers, because now we still go to this last step, and we ultimately want to say w equals this, whatever those solutions are going to be. Ella, what's one answer you wrote down? Good. So this gives us a solution of 3. Let's do this one here next. Assad, what would that one be? -3. And then here's where you now need to be careful. We have this factor out in front. Here's what we're doing with all of these. Remember what we would do with all these yesterday if we said we're going to do it the long way. I want to take w plus 3, set it equal to 0. When I solve that, we get the w is the -3 that Assad gave us. If I did w minus 3 equals 0 and I add 3 to both sides, that gives me the +3 that Ella gave us. Well, don't we have this third factor right here? So if I now set that equal to 0, and I said 4 equals 0, is there a variable there for us to solve for? No. So even though there is a factor right here, that does not produce a solution. There are only 2 solutions to this. Understand how that's a little bit different than yesterday, because yesterday, not only did we have a 4 here, and you're going to see these here soon enough, if there was an x here now, so don't change your problem because we don't have an x, but if there was an x attached to that, wouldn't this now go ahead and give us a solution? Because now wouldn't I divide by that? Wouldn't that have given us a third solution? So if there's a variable with that number out in front, you're going to get an answer of 0. If there isn't, don't think that that's going to produce an answer. Our only answers here are 3, -3. All right, moving forward, here's actually something that you want to understand. Notice how the biggest power is a 2. That means you will most likely get 2 answers. We do, but weren't those answers just the same thing? All right. This one, if I get 2, the most answers I could possibly get is 2. That's a power of 2. I can only get 2 solutions to this. Okay. When we get to this next one, so for number 3, this means I should get 3 answers because I have now a cubed. Do 3. See what you think about number 3. And this should give us 3 answers. If you don't get 3 answers, you got a problem. All right, you get 3 answers. Okay. Let's do this one. I've only seen one person so far with 3 answers nicely. Don't lose sight of your steps. As we add layers to all of these, what we're checking is, does it equal 0? It does. Are these in descending order? Are variables? They are. So then that takes us back to what we had done before all these equations, which is just going through trying to factor. And the first thing you look for is a GCF. So everybody that I looked at knew that we had a 3. That's a common factor. That was not a problem. A lot of people miss the B's though. If this has 3 B's and this has 1, don't they all have at least 1 B in common? So that's part of your common factor. So 3B should be what we're pulling out of our parentheses. And then what's left over, 3 times a 1 would give us the 3. And then if I had 3 B's and I pulled one of them out, I'm only left with a B squared. Then we would have our minus sign. If I pulled a 3 out from a 12, I'd be left with 4. I had 1B. I pulled the 1B out, so there are no B's left over for that one. All right, and then I'm just going to erase the 1 because we don't need it. It may be more confusing than anything else. That then gets set equal to 0. So that's our GCF. That's just following our order for factoring. The second thing, like we did in the previous problem, now identify if what's left over is a difference of squares. So understand what each word means. A difference means you have subtraction. We do. Squares mean that 4 is a perfect square, which it is, and the b squared is a perfect square, which it is. That means this goes further. So we're going to drop the 3b down, and then this should factor to be b minus 2, b plus a 2. Now we go through what we would have done for the homework yesterday, the first time kind of seeing this. So if I ask you this solution, Lily, what is the solution to this blue one? Good, positive 2. All right. Maddie, what is the solution to this yellow guy? Good, that would be a negative 2. So now understand the big difference between this one and number 2. So in this one, I had this 4 out in front, but was there a variable attached to this? No, that's why that doesn't give us an answer. If we look at the one now that we're dealing with, if I look at this variable out in front, notice how there is now a variable attached to this. So if we did set up this equation, just so you believe me and understand where this comes from, if we took that and set it equal to 0, if I now divide by that 3, doesn't that give us our third solution? And that third solution is going to be a 0. So 0 is an answer, 2 is an answer, and then this negative 2 is an answer. All right. It's largely the same stuff we've been doing. There's just so many different combinations and options that it's why it gets kind of tricky. All right. All right. Number 4, first trinomial that has a common factor. So this one does have a common factor, whether we know it or not. If you had your calculators, 27 does go into 108. So we're going to pull out a 27. This has 2 C's, this has 1 C, this has no C's, so they don't have all 1. So there is no common variable, so we're just pulling out a 27. We are then left with a C squared plus a 4C plus a 4. That would equal a 0. Again, here's a little guide for you. This here is telling you how many solutions we should end up with. All right, that x squared, or C squared in this case, there's 2 solutions to this. So we should get 2 values, sort of 2 solutions to this. All right, so we have that common factor. And then now in a trinomial, we're trying to find numbers that multiply to be 4, positive 4, and at the same time would add up to be a positive 4. Okay, so that should be about as easy as it gets. It's a positive 2 and a positive 2. So, Jake, what is the solution to this one?
C equals -2.
Good. C equals a -2. And it's weird. I said we should get 2 solutions. We technically do. It's just, what is the second solution also, Jake? Yeah, they're just both a -2. You don't then have to write both of them down. So once you identify that it's actually the same number, just produced twice, you can just write that one down as your answer. Okay? This does not give us a solution because it does not have a variable attached to it. Okay? That's, again, one of the things we want to make sure we understand. All right, then 5 and 6. If you look, these are the ones that some people had some questions on. These are a little nicer, a little shorter. But first and foremost, we have to have these set equal to 0. The first 4 problems equaled 0, equaled 0. If you look at 1 and 2, they all equaled 0. This one does not. So we need to move either the 3t squared or the 108. So we either have to move this guy to the right-hand side or we need to move the 108 to the left-hand side, one or the other, so that we get a 0. What's going to guide you in that decision is we want this squared term to be positive. Is it currently positive? Yeah, so you don't want to move that one because the only way we would move it is by subtracting it, and that would make it negative. So we want to keep this guy right where he's at. He's happy where he's at. He's a good positive guy right now. So we're going to move the 108 over. So we're going to do minus 108. That will give us the 0 that we need. That means I need to subtract 108 from the other side. Those are not like terms, so we just write that as a difference between those. 3t squared minus 108. Okay, go. Factor it, go through that. How many answers should we get here? 2, no more than 2. All right, see if we can factor that. Question, or are you going to give me some? Oh. So it's going to be harder to recognize. So if you did a negative 108 plus 3t squared, while algebraically that's 100% correct, there's nothing wrong with this. When we now go to our factoring methods, so the first thing we're going to do here, Caden, is look for GCF. So there is a 3 that's going to go into both of those, and this would be a negative 36 plus a t squared. Do not write this down. I'm just explaining. Try to do this one, everybody who's watching right now. Try to do this problem. It's going to answer Caden's question here. When I now ask you if this is a difference of squares, you're going to get confused by this most likely, because a difference means we're subtracting. If I have it written like this, it doesn't look like we're subtracting, right? Because it's a sum. So you're going to think I can't take that any further. But if we flip them around, so if I put the t squared first, and then I had that negative 36 second, doesn't that now look like a difference? Yeah, so that's why we do want to put the exponent with the highest degree first and then have them in descending order, okay? Yeah. Should get, again, 2 answers and only 2. No way we get 3 out of this. All right, GCF, I guess I kind of gave that away already in answering Caden's question. 3 does go into a 108, all right, 36 times. Same steps we would have followed over here. We do have a GCF of 3. We now look to see if this is a difference of squares. Hopefully we're getting better at recognizing that this is a difference of squares. So Julia, how would this guy factor further? Good. T minus 6, t plus 6, that's equal to a 0. And then now just be aware, this is a trick question. What solution would this factor give you? No solution, right? Because there is no variable there. So even though it's a factor, it doesn't give us an actual answer. All right, when I get to this one, actually, let's do this one first. All right, Jada, what is the solution to this guy? Good, positive 6. And then what would be the solution to this one, Jada? Good, and then those are the 2 solutions that this exponent was telling us we should end up with. All right. All right, having done that one now, do number 6. So not going to get you started. See if you can get through that one. What do we need to do first? Once you do it, then what do we do? I would consider this a hard one if I were to put it on a quiz. If we were able to get a quiz in tomorrow, which is normally when I would have given a quiz, I would consider this a hard one. I would think people would have a hard time with this one. So see if we're understanding. If you do, really good sign. How many answers should you get also? 3. So if you don't get 3, let's see what the problem is. Okay, we'll do it together. This, again, just kind of gives me an idea where we're at. Not quite there yet, which is okay. But what we are recognizing, which is awesome, because almost everybody I looked at did this, you understood that this 27y needs to get moved over. All right, so that's a good thing. Then you would have 12y cubed minus the 27y, and then that would equal 0. So everybody I looked at had that, so that's good. What we talked about, this should tell us how many solutions we should get. That should mean we get 3 different factors. So if you pull out your GCF, which most people I'm looking at are getting, which is also good, a 3 goes into both of those, and then they all have at least one y in them. So the majority of people that I'm kind of watching, that I saw, have that at least. So that's our greatest common factor. So I'm going to pull out a 3y. 12 divided by that 3 would leave us with a 4. 3y's reduced by 1, leave us with 2y's. 27 divided by 3 gives us 9. And then the 1y gets pulled out, so there are none left over. If I ask you how many factors are left right now, don't we just currently have 2 factors? That sort of helps a little bit guide you if that breaks down anymore. If there's supposed to be 3 different answers here, and I currently only have 2 factors, that's sort of a little hint telling you that this guy probably goes further so that we can get 2 more and then get to our 3rd factor. All right, so it does. This is, again, GCF first, and then you want to identify in a binomial, did we have a difference of squares? Is it a difference? Yeah, and then are these both perfect squares? Yes, so that factors further. So that initial 3y, I'm going to drop it down. All right, and then Joel, how does this factor further?
2y minus 3, 2y plus 3.
Good. 2y minus 3, 2y plus 3. So now, don't we have 1, 2, and then finally 3 different factors that should give us those 3 different answers we knew from the beginning we should get. Now, these are a little trickier. If you can do these in your head, awesome. This one you could probably do in your head. All right, that's going to be a 0. If you can do the green one in your head, feel free. All right, knock it out. But the answer is not 3, correct? Okay. So if you're not sure, if you can't do that in your head, this is now us probably wanting to go ahead like we did yesterday in the first handful of them, be a little more thorough, set up the equation, set it equal to 0, and then just go through those steps. So we would need to add 3, and then I get 2y equals the 3, and then at that step you've got to divide by the 2. So this is one. If you're getting pretty good at it, you may have been able to do it in your head, but if not, set it equal to the 0, solve that equation. Again, probably want to set this equal to the 0. We probably want to be a little more thorough. Once this coefficient is not a 1, we probably want to go ahead and do the longer steps here. Set it equal to 0, solve that equation, so subtract 3 from both sides. Divide by 2, and our second answer is -3/2. If you got that on your own before we started it, that's really, really good. Okay, you're understanding this really well. And if not, don't feel bad. Even on the test, I would find that a harder one. Okay. Jeez, taking a while. All right. 7, nice one. How many answers should you get in 7? 2 answers. Do number 7 real quick. Do 7 and 8. 7 and 8, I hope, crossing my fingers when I say that, are nice. So try 7 and 8 and see if we can get through those 2. Don't just worry about your numbers. Worry about your variables. How many pieces this one have? How many does this one have? So they each have at least how many? How many does this have? So you have $2. And this is how many? I have $1. So we have at least how many total? I have at least 1. Do you have 1? You have 2, but do you have at least 1? So since we have at least a 1, the 1b is also part of your factor there. So you want to pull out just not a 3, but a 3b. Then if I had 2b's, and I'll pull one of them out, how many would be left over? Erase that. And if I had 1b, and I pulled it out, how many are left over here? How many did I have? 1. We're already done with those because you are understanding it, which makes 7 and 8 pretty quick. Go ahead and try number 9. You probably have to stop there. I don't want to start those last ones. Because 9 I would consider a little bit harder. If you get 7 and 8 real quick. Okay, let's see how that first one went. Armando, what'd you do first? Good. Good. So there's a GCF of 3b. So we pulled that 3b out. What's left over for the first term?
3b parentheses b plus 3.
If I had a 3 pulled out? Yeah, so just a b, and then what? Good. And then the 3 set equal to 0. We should have 2 answers, so it's nice that we now have 2 factors. Those 2 factors should give us those 2 answers. All right, so this one, if we went ahead and set that equal to 0, so if you want to do that, go ahead. If I solve that, that answer is what, Armando? 0. And then the blue factor, if we set that equal to 0 and solved it, that answer would be what? -3. So that's that answer. It's just a simple GCF. It was definitely not a difference of squares because it's a plus sign. 3 is not a perfect square, so there's really not a lot tempting us to go any further with that. Also, if I know there's 2 solutions, all right, decent chance then that I have those 2 factors. I don't need to go any further. All right, 8. We do want to look for a GCF here, but as soon as I see there's just a 1 right there, there's really no chance of a GCF other than the 1. If we look at our variables, m squared, m, no m's, since they don't all have at least 1 m, there is no GCF in this problem. So then this now just goes to us, this was your homework last night, just factoring a trinomial. So we want to come up with numbers that multiply to be a positive 100. And then at the same time, they would multiply to be a negative 29. All right, saw a few people with that. What does that give us, Armando? Good. Negative 25 times a negative 4. Multiply those, you get the positive 100. Add them, you're going to get a negative 29. All right, so then we go through identifying what our solutions are going to be. This one is what, Armando?
25.
Good, positive 25. And then this one would be positive 4. Those are the 2 solutions that was hinting we should get. All right. Okay, last one we'll probably have to stop at. Number 9. Always look for a GCF first. I kind of hinted at this when I told you to do it. We do have one. I would think even numbers are always going to be the easiest to identify. These we can all pull out a 2 from. So you're going to pull that out. And then you get x squared plus a 4x and then plus a 3. This is telling us we should get 2 answers. We currently have 2 factors, right? But would the 2 give us a solution right now? No, because there's no variable with it. So that's telling us to get another factor so that we can solve this, that the trinomial probably factors further. And it does. So in terms of numbers that multiply to be a positive 3 and then add up to be a positive 4, that would be a positive 3 and a positive 1. And then again, just be aware, there are 3 different factors here. All right. One of them doesn't give you a solution because we can only get the 2 solutions. The 2 doesn't give you your solution. So CHAM, what is that solution, CHAM? Good. And then the purple one is going to be what? Good. And then those are your 2 solutions. All right. Okay, no homework. Even if we had gotten to these, I wouldn't have given you homework. Bring this tomorrow, though. This is probably what we'll do Monday. We would normally have quizzed on Tuesday. We're not going to do that because you don't have school on Tuesday. But that does mean we probably just go right into the test on Friday because we're largely done with all of this, and now it's just kind of putting it all together. So heading into next week, just know you probably have a test at the end of next week. All right, but no homework for this weekend. You're free. Yeah. Let me